Hi everyone, welcome to Geek Maths. We are going to start off with AMC 8 1995, question number 21. Okay, uh, a plastic snap together cube has a protruding snap on one side and a rectangle holds on the other five sides. What is the smallest number of three these cubes that can be snapped together so that only one receptacle hole only, only receptacle holes are showing? So you should not see this, right? That's the purpose. So if I shouldn't see this, so I can have um so see, for example, I have a cube here. Okay, now these are all holes. Now this is the protruding part, right? Now if I don't want to see this, okay, now I'm going to fix this is my second cube, so I'm going to fix this in one of the receptacle holes like this. Okay, so this is fixed inside, but this one is going to protrude out, right? This is going to protrude out. Okay, they don't want to see such protrusion. That's what they mean. Okay, now let's go one by one. So if I take 3, right, so what I'm going to do, I'm going to place one more here. Okay, so that is a protrusion here. So this one I will place a receptacle on top of this. Correct. Now this one will also have a protrusion, so that can either be here or here or wherever. So suppose I'm going to assume the protrusion is here. It's protruding like this. Okay, now let's take the example of 4. So if I get a 4 here, what I can do is, for this protrusion I can put a receptacle. Correct. Now this protrusion goes here, this protrusion goes here, this protrusion, so there is a receptacle which goes here. Now there is a protrusion, now there is a receptacle here, right? So I can put that here. Are you getting? So see this here, if I have the fourth, I can put, so this is the protrusion of this, the protrusion of this can go here. Correct. So when I have 4 cubes at a minimum, this will all get connected into each other and I won't be able to see this. I will only be able to see the holes on each side. So that is the question. That is what they're asking. So answer for this is B4. Going to the next question. Coming to question number 22. The number 6545 can be written as a product of a pair of two-digit numbers. What is the sum of this pair of numbers? Okay. So two numbers, positive two-digit numbers should be multiplied to get this number, and it should be two-digit numbers. Okay, two-digit numbers should be multiplied to get this number, and we have to find the sum of those two numbers. That's the question. So first, I'm going to say, I'm going to prime factorize this. Okay, 6545 prime factorization. You know how to do prime factorization. I'm not going to go into that. So I'm just saying 6545, this is equal to, so when you prime factorize, you'll see that you're getting 5 7 5 into 7 into 11 into 17. These are the 4 prime factors which you're going to get. This is going to give you 6545. Okay, now we know the 4 numbers. Now multiplying, these two numbers and these two numbers, for example, I'm just going by trial and error here. So if I'm going to say 5 into 7, so this becomes 35. Okay, and multiplied by the other. Now if I multiply 11 into 17, I'm going to get 187, but this is a 3-digit number, right? So this is not going to work. Okay, similarly, if I take, say, 5 and 11, which becomes 55, and then I'm going to say 7 into 17 becomes 119. So this is also a 3-digit number. This will not work. So now let me take 17 and 5, 11 and 7. So 11 and 7 becomes 17, 77, and 17 and 5 becomes 85. Right? So these two also, if you multiply, are going to get 6545, and these are both two-digit numbers. So this works. Okay. So your answer will be 77 plus 85, which is equal to 162. Okay, which is your answer over here. Answer option A. Question number 23. How many four-digit whole numbers are there such that the leftmost digit is odd, the second digit is even, and all four digits are different? This is a counting problem. And how do we do this? We have to use, you know, a simple technique. So there are four numbers, right? So four digit whole numbers. So for each of the numbers, we are going to try what can fit in, okay, for each of the digits. Now it says there are such that the leftmost digit is odd. So this has to be odd, okay. So how many odd numbers are there from 1 to 9? Because here the first digit cannot be a 0 any which ways, right? So 1, 3, 5, 7, 9. So only 1, 3, 5, 7, 9 can fit over here, correct? So that's how many combinations, how many possibilities? It's 5, okay. Now second digit is even. So even can be 0, 2, 4, 6 and 8, correct? So this is also 5 possibilities. Then all four digits should be different. These two can contain anything, doesn't matter. So one number is already gone here, right? Okay, remaining how many numbers are there? Totally, so one number is gone here, correct? And one number is gone here. So that leaves us with how many numbers? So you have 0 to 9, which is 10 numbers, out of which one number, any one number is gone here. So that gives here 8 possibilities, correct? Now three numbers are gone, 1, 2, 3. Out of 10, three numbers are already occupied. That gives us one number here, which is 7, correct? So now we'll check. So 7 5s are 35, 8 5s are 40. So we'll say 35 into 40. I'm just multiplying these, right? These are the possibilities. So I'm going to say 0, 0, 14. So it's 1400 possibilities, 1400 numbers. Got it? Going to the next question. In parallelogram ABCD, DE is the altitude to the base AB and DF. AB and DF. Okay, so this is the base and this is the height. Now let me just make this a little smaller so it's easier to write on this. Okay. Okay. So um, if DC is 12, okay, so this is 12, and same thing is this, right? It's the same um, parallelogram shown from two different angles. Okay, so these are not two different parallelograms, it's the same. You see the numbering, it's the same. Only thing is we are showing this one in a different direction, that's all. So um, D is the altitude to the base AB, DF is the altitude to the base BC. So this is the base for this one and this is the height. Okay, now if DC is 12, EB is 4. Now this is 4. Okay, DE is 6. So this is 6. Right. Then DF is equal to. So what we have to find? We have to find this. We have to find this. Okay. Now for and they say this is all parallelograms, right? So for a parallelogram, the opposite sides will be equal. So this thing will be 12. AB will be 12. Okay. So what will be AE? This will become 8. Correct? Because we have 4 here. Now because we know 8 and 6, can we find this? So it will be AD will be, we'll use the Pythagorean theorem here, Pythagoras theorem. So AD will be equal to the square root of 8 square plus 6 square, which will give you 10. Okay, so AD will be 10. Now I'll just write this here. So here AD is 10, which means BC is also 10. Okay, this is 12. Now look at this one. We can find the area, right? Because for a parallelogram, um, base into height, right, is going to give you the area. Because for a triangle, it is half into base into height, but for a parallelogram, it's base into height. So we'll say that what is the area of this parallelogram? It's the same parallelogram, so I can find the area from here, right? So the height here being 6 and the base here being 12, so 12 into 6 area, which is 72. Okay, now we know the area is 72. We have to find df, which is the height for this base, correct? So we'll say uh, 10 into db, no, df is equal to 72. So what will be df? Df is equal to 7.2. That's the answer. Okay, going to the next question. Buses from Dallas to Houston leave every hour on the hour. Okay, so when it is leaving, it's leaving every hour. So one bus an hour, and it leaves on the hour. On the hour means say 1 o'clock means the bus leaves at 1. For 2 o'clock, it leaves at 2, and so on. Buses from Houston to Dallas leave every hour on the half hour. So when do they leave? They leave every hour. Okay, so again, one bus an hour, but they leave on the half hour, which means first bus will leave at 4:30, then at 5:30, then at 6:30, and so on and so forth. Okay, the trip from one city to the other takes 5 hours. Assuming the buses travel on the same highway, how many Dallas bound buses does a Houston bound bus pass in the highway, not in the station? So we are not looking at the meeting in the station, but we are looking at the meeting in the highway when they are traveling. Okay. Now understand that both directions there are only a bus an hour. Okay. That is the number for first thing. Second thing is a total journey takes 5 hours. Okay. So let's build a scenario here. I am okay. So this is Dallas and this is Houston. Okay. And this is where the buses are traveling. So the first bus here, okay, from Houston, suppose starts at 12 noon. Okay. So what time will it reach Houston? It's 5 hours, right? So it's going to reach at 1, 2, 3, 4, 5. Okay, 5 p.m. 5 p.m. So it will obviously, so it Houston every half an hour a bus is coming, right? So it is going to meet here. This bus, when it is going like this, it is going to meet the Houston buses which are coming from this direction. So that is what they want. How many buses in this span of 5 hours is this are we going to meet? That's what they want. Okay, so let's check. So 12 o'clock this comes, and then this starts traveling, right? Now when this reaches like half an hour, when it is into the travel for half an hour, imagine this bus. Okay, so we back count. So there would have been a bus from Houston which had started 4.5 hours back, right? It starts at the half hour. So let's back count from 12. So 11, 10, 9, 8. So suppose I have a Houston bus starting at 8:30. Okay. Now what time is it going to reach Dallas? It takes 5 hours, right? So it's going to reach 8, 9, 10, 11, 12, 1. No, 9, 10, 11, 12. Uh, so I think we can go till 7:30. So suppose a bus started at 7:30. It will reach Dallas at what time? It will reach at 2:30, right? No, sorry, 12:30. Correct? So 8, 9, 10, 11, 12, 12:30, right? So if it is going to reach Dallas at 12:30, but this bus has started from Dallas at 12, will it meet that bus? Yes, it will. So this is one scenario. Similarly, I have something starting at 8:30. Okay. So when you start at 8:30, this is going to reach at what time? 1:30. Correct? So 1:30, this bus is still traveling and going this side 1:30. So this will meet. Then we come to 9:30. Okay. So this is going to be 2:30. Okay. This will also meet. Then we come at 10:30. Okay. Now this will be 3:30. This will meet. Then 11:30. Now this is going to meet at 4:30. Correct. Now let's come to 12:30. This will only reach at 5:30, right? But this is already reached at 5 p.m. So will it actually meet? It will meet. You know why? Because it is going to start from here at 12:30, right? So at 12:30, this bus is still not here, right? So what is going to happen towards the end of this? That will be this bus which has just started. So this will also meet. You see that? So either the ending point it can match within, fall within this, or the starting point also can fall within this, because this would have traveled the longer distance and this bus would have just started. It's starting at 12:30 only, right? So 12:30 this bus is still traveling, isn't it? So that is the reason. So there is another bus here which is traveling. So that will also meet, right? So this is also going to happen. Now let's say 1:30. Okay, so I'm not going to write this, might seem confusing, but just look at this 1:30 here, right? So this 1:30 it's again going to meet, right? So this also got on. Then we'll say 2:30, here also it's going to meet. Then 3:30, 2 3 4 5 6 7:30. Then this is going to be 8:30. Now let's say this is 4:30. Okay, and this will become 9:30. Okay, but 5:30 will not happen, because 5:30 this one is already reached. Okay, so how many possibilities we have? 1 2 3 4 5 6 7 8 9 and 10. Okay, so this 10 times this buses are going to see the bus from the opposite direction. So your answer is 10. I hope this is clear. It's a little tricky problem. So this every hour is very important. Don't miscount by thinking that from Houston every half an hour a bus is leaving. No, every hour the bus is leaving, but on the half hour. Okay, so that's very important to understand and read the question properly, and this is how you solve. So while it is traveling, what are the buses? So when this is traveling, there could be always two buses on here, right? Because every hour another bus is coming, so totally it means 10 buses. That's the meaning. Thank you, we'll see you in our next video. Bye, have a great day.